In this video, we're going to take a look at some decision trees for helping farmers, landowners, their advisors, and conservation professionals in selecting what edge of field practices to consider and that might be suitable for a particular site. Farmers and landowners are presented with a laundry list of conservation practices that they are encouraged to consider adopting. But with all these options, it can be overwhelming trying to think about what might make sense for their farm among all the other considerations that they have in running their operations and trying to remain profitable. This is especially true for the edge of field conservation drainage practices like bioreactors, controlled drainage, multi-purpose oxbows, saturated buffers, and treatment wetlands, which are often more unfamiliar and have more siting constraints to know where they will work. So then to help with that, Iowa State University and the Iowa Soybean Association collaborated to develop some decision trees for farmers, landowners, and conservation professionals to help in selecting potential edge of field practices that they might consider. Because edge of field practices generally require more technical assistance for siting, design, and construction, the decision trees can't and they won't definitively select a suitable practice. But instead, they can help narrow down the practices that best match the farmer or landowner's goals and that have the best potential for success to help inform the conversation once they do engage technical assistance of a conservation professional. These decision trees are a part of the Whole Farm Conservation Best Practices Manual, which was developed as part of an NRCS Iowa Partners in Conservation grant and led by the Conservation Learning Group at Iowa State. The manual provides information on a range of conservation practices and includes decision trees for infield as well as edge of field practices. Electronic copies are available for free at the Iowa State Extension Store. For this video, we'll focus on the decision trees for edge of field practices for reducing nitrate loss from drainage systems. The first decision tree is used to help narrow down practices based on how well they'll meet or match the farmer or landowner's goals. So it starts by asking what their primary goal is. If their primary goal is improving water quality, then any of these practices will work to improve water quality. If providing habitat is a primary goal, then wetlands, oxbows, and buffers are practices that will provide habitat benefits as well as water quality benefits. If the farmer is interested in adding water management capability to the drainage system to potentially help increase crop yield in some years, then controlled drainage can provide that while also benefiting water quality and can potentially also be stacked with other edge of field practices. In looking at practices for water quality, this decision tree can help narrow down the one or ones that may be the best fit. So the first question is whether the landowner is willing to put some land into a long-term easement for the conservation practice. If they are, then that would be a great site to consider for a treatment wetland. Treatment wetlands have the potential to treat more acres for multiple fields, as well as providing multiple benefits for habitat and other ecosystem services beyond just water quality. The next question is whether there are any stream or adjacent depressional areas that may have been an old oxbow. If so, then restoring these oxbows is a good opportunity to provide riparian and aquatic habitat in addition to treating drainage water. If there's an existing stream side or ditch side buffer, then that would be a good site to look at for suitability for a saturated buffer. And if none of those apply, but there is about 1/10 of an acre somewhere near the drainage outlet, then the site can be considered for a bioreactor, which can often be adapted to more sites than the other practices. Otherwise, alternative practices like some of the infield practices would need to be considered. If treatment wetlands are a practice of interest, this decision tree can help in considering site suitability. For this and the other decision trees, there's a series of yes-no questions that are used. If the answer is I don't know, then that would be a point to stop and contact your local conservation office for technical assistance. So the first question here is whether the potential location is a site that would be leaky, so sites such as sands or gravels or karst areas where it would be difficult to hold water. If yes, then an alternative practice should be considered. If no, then the next question is whether it's a location where tile drainage could be captured for treatment. If the answer is no, it's still a site to consider for a wetland for habitat and other ecosystem services, even though it wouldn't be treating drainage water. If tile drainage water can be captured and directed to the wetland, the next question is whether that can be done in a way not to impact the drainage of others. For example, having enough drop not to back up and submerge upstream outlets. If it will likely affect the drainage of others, then an alternative practice should be considered. But if not, then the site is a good candidate for a treatment wetland. The next decision tree looks at multi-purpose oxbows that can capture tile drainage water for treatment, as well as providing oxbow habitat. So the first question should be fairly obvious, but you need to be located along a stream or river. If not, then you'll obviously need to look at other practices. If yes, then the next step is to determine whether areas of old oxbows can be identified, either from noticeable depressions seen from walking the area, or often they can be identified from aerial or satellite imagery. If not, then consider alternative practices, but if so, then is there evidence of excessive stream erosion, such as steep banks, sloughing, outside bends, or undercuts? If so, then that's not going to be a good site to build an oxbow. But if not, then it may be a good site for an oxbow, and you can consider whether tile drainage water can be captured for treatment. If not, then still would be good to consider the site for an oxbow for the habitat benefits. But if there are drainage outlets where the drainage water can be captured and directed to the oxbow, then it would be a site to consider for a multi-purpose oxbow for those multi-purpose benefits. For saturated buffers, the first question is whether there's an existing buffer or if the landowner is willing to put in a buffer. If not, then obviously it won't be suited for a saturated buffer, but if so, the next question is whether there are surface intakes on the drainage system. If not, then the site can be investigated for a saturated buffer. If there are intakes, then willingness to use alternative intakes or other measures to control sediment should be considered to be able to protect the buffer distribution line from sedimentation. If the landowner is not willing to do that, then alternative practices are going to need to be considered. But if they're open to sediment control measures, then a saturated buffer can be considered. Then for bioreactors, the first question is whether there's an area near the outlet where it can be located. If not, then obviously something else should be considered. But if so, then similar to saturated buffers, there's a question about surface intakes on the system. If there are intakes, then again, alternative intakes would need to be considered. And if that's not a possibility, then other practices should be considered. If there are no surface intakes or alternative intakes or other measures are used to control sediment, then the next question is whether the drainage outlet is 10 inches or less. Because of the capacity limitations in the NRCS Conservation Practice Standard, this is the range most likely to work with a traditionally sized bioreactor. And so this would be a good site to then consider for a bioreactor. If the outlet is bigger than 10 inches, then alternative designs such as dual or multi-chambered bioreactors could be considered, but those are going to come with more expense, they're going to require more area, and they'll take more management. So if the landowner's not open to that, then another practice should be considered. But if they are, then a bioreactor could still be a consideration. And finally, for farmers interested in the management capability of controlled drainage, the first question is whether they have a good map of the drainage system. If not, because of the challenges and expense needed to do a thorough investigation that would be needed to characterize the drainage system to design a controlled drainage retrofit, it's probably best to consider another practice. If there is a good drainage map, or it will be a newly installed system that can be designed for controlled drainage and then would come with a good drainage map, the next question is what the land slopes are where the system would be located. Controlled drainage works best on slopes of 1% or less, but can sometimes be implemented on slightly steeper slopes at added expense. If slopes are steeper than 0 to 2% or A slopes from a soil survey, then it's likely not going to be a good site for controlled drainage. But if the site's relatively flat, then controlled drainage could be considered. So that's an overview of the edge of field decision trees. Again, for more information and for copies of the decision trees, download the Whole Farm Conservation Best Practices Manual.